you need another example to make sure you get the entire process down pat. So I've got another similar problem. I'm asked to find all the zeros for the polynomial. It's a degree 4 polynomial, so it should have a total of 4. First thing is to make that P over Q list. So remember, P is the constant term at the end. Q is the leading coefficient, and in this case your leading coefficient is 1. So that kind of helps out when you're making the P over Q list, because when you're doing plus and minus factors of 10 over plus and minus factors of 1, it's really just going to fall into the plus or minus factors of 10 itself. And your factors of 10 are 1, 2, 5, and 10. So since I'll be making fractions with these numerators all divided by 1, then the only possible rational zeros should be one of these 8 numbers, plus or minus 1, 2, 5, or 10. All right. Now, back in the day before we had these nice calculators, what algebra students would have to do was to try each of these with synthetic division to see which one actually gives you a zero remainder. But I am allowing you to locate those rational zeros by looking at the graph. So as soon as you get your P over Q list made, go ahead and graph out that polynomial. So I'm going to go to y equals, and I want to type in this polynomial equation. So let me clear out my last one. That is x raised to the 4th, and then minus 4x to the 3rd, and then minus x squared plus 14x and plus 10. Okay, so I think I've got it typed in there the right way. Yeah, always double check the way you type in your polynomial, because one tiny sign error or misplaced coefficient is going to, well, just mess up the whole works. So now let's go ahead and graph it in zoom standard first. See where those zeros fall. So this is a degree 4 polynomial, and it's up on the left and up on the right, and it only appears to touch the x-axis once. So let me zoom in using zoom decimal, zoom number 4. Okay, so yeah, this polynomial, it only touches the x-axis once. So, and we're supposed to find a total of 4 zeros. Well, at least this value is in our P over Q list. It looks like it's at x equals -1. So if I trace it to -1, it does check out. There's a -1 and a y value of 0. So I know we actually get, you know, at least one rational zero to use. X equals -1 is the only rational zero that we find. So it says to use synthetic division now to take out all the rational zeros, but we've only got one. Remember, the graph looks something like this. There was our calculator screen. Here's the -1. The graph comes down, touches at -1, and then goes back up. There's something very noteworthy about that. Remember, whenever a graph of a polynomial touches at a 0 without actually going all the way through, that means you have multiplicity 2. At that 0. What that means is when you're doing the synthetic division step of taking out all the rational zeros, then you actually get to use this number twice in 2 consecutive steps to go from degree 4 to degree 3, then to degree 2, to set that quadratic quotient equal to 0 to get your remaining zeros. So remember those properties of polynomial graphs. Whenever you see the graph just touch the x-axis at a certain 0, that means you need to use the multiplicity of that 0 to tell you how many total times to use it with the synthetic division. So I'll start off with x equals -1, set up my synthetic division array. The coefficients, let's see, 4, 3, 2, 1, 0. Everybody's there, no missing terms. So my coefficients are 1, -4, -1, 14, and 10. And I am anticipating a 0 remainder right here because x equals -1 is a 0 of the polynomial. So start the process. Bring down the first coefficient. -1 times 1 is -1. Those add up to -5. -1 times -5 is 5. Those add up to 4. -1 times 4 is -4. These add up to 10. -1 times 10 is -10. And indeed, I do get a 0 remainder. So now, remember, we've taken degree 4 down to degree 3. But the only way to get those other two zeros is to set a quadratic quotient equal to 0. So remember, when you have multiplicity 2, that actually tells you you get to use that 0. In this case, x equals -1. You get to use it in that many number of steps in your synthetic division process. So I'm going to start over, well, not all the way over. I want to start with my cubic quotient right here, and then take out x equals -1 one more time. Still knowing that I should get a 0 remainder when I'm done. So when I take out -1 in this consecutive step, bring down your 1. -1 times 1 is -1. Those add up to -6. -1 times -6 is 6. Those add up to 10. -1 times 10 is -10. And yes, I get a 0 remainder. So our quadratic quotient is 1x squared minus 6x plus 10. And since our goal is to find all the zeros of this polynomial, I need to set that quotient equal to 0 and solve for the remaining ones. So again, once you get down to the quadratic level, that's very familiar territory for all of you. And this is actually one you can solve by completing the square. You can always use the quadratic formula if necessary, or I guess in a rare case, factoring. But this one won't factor. There are no two numbers that multiply to 10 that add up to -6. So, but I'm going to take advantage of the fact that I've got a 1 on my x squared and an even coefficient here and use completing the square. But again, you can use quadratic formula if you so choose. So get your x squared and x on the left, subtract the 10 from both sides, and here's my completing the square process. My half number is -3. I need to square that and add it to both sides. So that guarantees the left-hand side is now x minus 3 quantity squared, and the trade-off is the right-hand side is now -1. And so yeah, well, my next step is to take the square root of this number, and that guarantees the other two zeros never showed up on the graph. The other two zeros have to be complex because we have one rational zero, one real zero that has multiplicity 2, and since this has degree 4, if the other two zeros never showed up as an x-intercept, that means they're not irrational, they're actually going to be complex. So take your square root of both sides. The square root of -1 is plus and minus I. Don't forget your plus and minus when you take a square root. So then add 3 to both sides, and you've finished the list. X equals 3 plus I and 3 minus I are the other zeros for this polynomial. So the goal was to find all the zeros, and since our beginning degree was 4, don't forget to list multiplicity 2 for the x equals 1. So just say x equals, or -1, excuse me. For the x equals -1, 0, maybe put the abbreviation M2 next to it to guarantee that it counts twice toward the degree of 4. And then the other zeros are x equals 3 plus I and x equals 3 minus I. But you can list those as the plus or minus pairing if you'd like to. And that completes the set of zeros that we have for this polynomial.